A number of creation scientists have acknowledged a heat problem associated with the global flood described in Genesis chapters 6 to 9. At BCT, we have produced this short video to explain how this problem arises and its magnitude. Consider three key points from the Bible narrative: the implied rapid and violent geological changes, starting from Genesis 7, verse 11, the accompanying large-scale deposition of heat, and the survival of all on the ark and many aquatic creatures. The objective of our research program on this topic is to seek a coherent scientific description of how the flood heat was removed. Genesis 7 verses 11 and 12 describe the onset of the flood like this: in the 600th year of Noah's life, in the second month, on the 17th day of the month, on that day all the fountains of the great deep burst forth, and the windows of the heavens were opened, and rain fell upon the earth 40 days and 40 nights. Genesis 7 goes on to describe the state of the earth when the floodwaters had reached their maximum depth. The waters prevailed so mightily on the earth that all the high mountains under the whole heaven were covered. The waters prevailed above the mountains, covering them 15 cubits deep, and all flesh died that moved on the earth, birds, livestock, beasts, all swarming creatures that swarm on the earth, and all mankind. Only Noah was left, and those who were with him in the ark. And 2 Peter 3 gives a New Testament view of the flood and its worldwide effects, both on the earth and on its inhabitants, including most of mankind. They deliberately overlook the fact that the heavens existed long ago, and the earth was formed out of water and through water by the word of God, and by means of these, the world that then existed was deluged with water and perished. An important source of flood heat is cooling magma, hot, partly or completely molten rock from below. This photograph shows an example of an erupting volcano in Ecuador. The lava, or surface magma, will cool and solidify after the eruption. The many volcanoes likely erupting during the flood would have deposited lots of heat. This is an underwater volcano erupting explosively near Samoa in the South Pacific. The lava erupts at a temperature of 1200 degrees Celsius. It's likely that during the flood, many mid-ocean ridges opened rapidly as the tectonic plates beneath pulled apart, allowing large masses of magma to pour out and cool to produce today's ocean floors, depositing a vast amount of heat in the process. Another form of heat deposited by cooling magma arises in underground or plutonic formations. This sketch shows various types, number 6 being the volcanic neck inside a volcano. The largest type is a batholith, number 3, which covers at least 100 square kilometers. The Sierra Nevada batholith in the western USA covers about 60,000 square kilometers. Here we summarize the estimated total heat deposition due to cooling solidifying magma, most of which is due to ocean floor cooling. Its magnitude and potential impact are clearly overwhelmingly large. If transferred rapidly, more than 30 times enough to completely boil off Earth's oceans. The next major heat source to consider is radioactivity in crustal rocks, how and where it arises, mainly from the uranium, thorium, and potassium in the upper continental crust, its contribution to the surface heat flow, and how it compares with heat due to the Earth's cooling. This pie chart shows the relative sizes of the contributions from the main heat-producing radioactive nuclides. Potassium-40 and rubidium-87 are beta emitters, while uranium-238, uranium-235, thorium-232, and samarium-147 emit alpha particles. Here's a summary of the basic conclusions of the RATE project scientists, that's radioisotopes and the age of the Earth, regarding radiogenic heat released during the flood. The evidence suggests that decay rates were hugely accelerated and that 500 million years worth occurred during the year of the flood. So a key question is, what effect would we expect this amount of heat, released mainly in the Earth's upper continental crust, to have on granitic crustal rocks? Well, we can compare it to present-day radiogenic heat production and note that the total is enough to melt these rocks 11 times over. Again, it looks overwhelming. The third likely major source of heat during the flood is bombardment from space. These photographs of the moon on the left and Mercury on the right illustrate the past histories of these rocky bodies in the inner solar system, their surface craters, and the lunar maria, the large dark areas on the moon, are evidence of numerous impacts due to impacting bodies of a wide range of sizes. Here we note the evidence of a history of bombardment from space in the surface craters of the solar system's rocky inner planets. In point 2, we note that the Earth has far fewer such craters than the other bodies, probably because many have been erased by its very active tectonically controlled geology. Point 3 gives a rough estimate of the number of larger impacts likely to have deposited significant impact energy on Earth. The best-known example of a major impact on Earth is represented by the crater at Chicxulub in Mexico. This artist's illustration depicts the asteroid fall thought to be responsible. Here's a summary of what we can say about the Chicxulub impact, commonly assumed to be the asteroid that killed the dinosaurs. We note the estimated impact energy, the resulting heat deposition, and some major environmental consequences. In point 1, the KPG boundary is the boundary between Cretaceous rocks below and Paleogene rocks above. And here we summarize what can be said about the heat deposited on Earth by bombardment from space during the flood. The estimated total is smaller than from the other two sources, but this figure is a minimum, and the true value could be up to 40 times larger. Impact heat could have had extremely serious effects. So, to summarize our conclusions, heat from cooling magma, largely due to ocean floor formation, amounts to more than 30 times enough to boil off the oceans. Heat due to accelerated nuclear decay is several times enough to melt the upper continental crust. Heat due to space impacts is subject to large uncertainties, but likely to produce major environmental effects. The resulting big challenge for creation scientists is to develop a coherent description of how all this flood heat was removed. We have not yet found a cooling mechanism providing an adequate solution. Hence, our research into the flood heat problem continues, surveying the relevant geological evidence and assessing possible cooling mechanisms with a view to identifying one or more routes to a satisfactory solution. You can find out more on this subject by reading Bill Worraker and Richard Ward's paper on modelling ocean floor cooling in the 2018 Proceedings of the International Conference on Creationism, and in Bill's 4 papers on the heat problem in the Answers Research Journal, which are all available online.